Eileen, if you could run to the library at some point, it doesn't have to be right now, and just see if I have printouts up there. Thanks, kiddo. Can you guys see it? Is it too small or is it okay? A little bit bigger? Okay. So, you guys can see the first ones are just matching. Let's get somewhere around there. Okay. So, number 6 was supposed to be C. Number 8 was supposed to be D. Problem solved with me real quick. These were little puzzles. You were just trying to make it match. What was the difference between 6 and 8? How were you supposed to know that they went with the matches that they went with? Center. Yeah, all about the center, right? Because they had the same A, they had the same B. They were both squished. Which way were they squished? If you didn't write it down, or if you did, you can look at it. Were they longer? Was the major horizontal or vertical? Yeah, the bigger number, remember? In the ellipses, you're looking for the bigger number. So the major axis was horizontal, so it was squished horizontally. This one, though, was in the middle, center. Sorry, 0, 0. I said center. This one was left 2, down 2, so then that one was translated back. Number 14. They gave you clues, and you were supposed to find an equation. So they gave you H and K. They gave you the foci. From the foci, you had to think about, okay, wait, if one's at 2 and one's at -2, that distance is 4, so C must have been 2. They gave you the length of the major axis, which you guys helped and corrected me real quick yesterday. The major axis is the entire length across count the diameter, which means the radius would have been 5, the major radius. Plug into your formula. They kind of rearranged it, but still C squared equals A squared minus B squared. You could have found what B was. Then they went ahead and plugged and shoved. And if you guys notice, B ended up equaling the square root of 21, which when squared just becomes 21. A, since it was 5, A squared would have been 20. If you guys tried to get standard form, you would have had to multiply by 210, probably 25 times 21. That would have been kind of gross. But you could have gotten that pretty standard form. They stopped, we'll stop. Sounds good. Number 26, no questions yet? Okay, number 26. What was different about the clues on this one? Well, the center, that's kind of normal though. They gave us the minor axis, which was kind of weird. So they gave us a clue about B, because it's half of the entire length. But didn't they also give you the vertex? That was kind of weird. A little bit. But couldn't you have figured out the distance from this y value to that y value? That's the only thing that changes. And that's how you would have gotten A's 3/2. From the minor, you get the B. Looking at, I don't know if I told you the orientation, but looking at the points, this is where the visual comes in, at least in my mind at least. Because you would have gone to -1 and written it there, and then where would this one be? Yeah, so the same x value, but you would have gone up 1/2, which is approximately there. And if that's the vertex, and yesterday I talked about how the vertex was the major axis, then you would have known that this A needed to go underneath the y or underneath the vertical. Because it's going up and down instead of going right and left. Or if you had compared the two, you could have figured out which one was smaller, which one was bigger. But the key as to how to put each of these variables with 3/2 going under the y and 1 going under the x, I think is found in the points and how they're oriented. Are we good on 26? Did yesterday kind of help you guys in how they look the 4/9? Because it's over and then we flip it? Okay. You only have 2 more? Ugh. They're intense. Here's 38. Let me zoom out just a little bit to see if we can fit it. Not sure if we can see it all, but we can see the beginning of both. Which one was nicer in working on, 38 or 48?
38.
Oh yeah, all the way. Because 38 was in that nice factored form. You can see your H, you can see your K. I just don't know if the sound is working because I think I turned it off. Oops. 48 needed completing the square. Questions?
For 38, I mixed up A and B, how do you know which one's A and which one's B?
Good question. I just kind of go with wherever the value is. So the 12 is underneath the x, and then remember we have to square root these because this is a squared, b squared, b squared, a squared. I just kind of look at it to say, okay, which one's bigger? That one's going to be a. And where is it? Under the y. Does that make sense?
Yeah.
So then we knew that the y, we needed to go up 4, down 4. So the nice thing is exactly where this is, in the sense of orientation, I know that the 4 needs to go with y, even if I haven't registered the major or minor exactly. So I know the 4 needs to be vertical. And then that one's nasty, the root 12, that'd be 2 root, oh, it's right there, 2 root 3. Maybe I figure that as a decimal just to kind of like approximate. It's definitely less than 16. And Sean, what'd you get as your decimal? Do you remember?
No, I just use that as like an approximation to.
Yeah, it was like 3 point something, right? Like 3.5-ish.
It was close to like 3.46.
We can do root 12 real quick in a calculator. Calculator. I was guessing 3.5. 3.46. There you go. So 3.5's not bad, yeah. So you can go 3.5-ish on the x on one side, 3.5-ish on the other side. And then you can find your c, and from your c, then you can go ahead and find your foci by adding, not horizontally, vertically. Adding and subtracting since the major is underneath the y. How many of you guys found yourselves looking to those formulas with the h's and the k's and the plus or minus c's? Okay. If you're looking at the formulas, maybe you'll grow out of that, but maybe you won't. It's not so much growing out of it, it's more like just how your mind works. You might prefer the formulas, just a heads up. Maybe start writing those on formula cards, okay? And for those of you that are graphically, just make sure you're getting it right. Because the formula is a kind of surefire way if nothing else is working. I think that's the end of 38 because that's the graph. Whew, look at that little baby guy. Anyway, number 48, you had to complete the square. So they grouped the x terms, they grouped the y terms, they pulled out the coefficients that were shared in the x terms like we did yesterday. Same thing with the y's, they moved that 60 over because they said, it's all mixed up. They went ahead and completing the square. Now they did that really fast, but they completed the square by adding the 4 and adding the 1. They offset by 4 times 9 and 25 times 1. Now that was weird. Anybody have trouble with that, Sean? There was no denominator. Like what? But remember from over, oh, it's not that one. The one up above where we had the 4 on top and the 9 on bottom. We could see this as a 9 on top and a 1 on bottom, so we can see it as 1/9 in the denominator. 25 on top, 1 on bottom, we can see it as 1 over 25. Then you can say, oh, 1/3 is my minor. Nope, sorry, that's bigger. 1/3 is my major, 1/5 is my minor. Use your formula to find C. And that's why, guys, this little baby guy is just because he's just, let's see, 1/3 is underneath the x. He's 1/3 right, left. And he's 1/5 up, down. Little baby guy. Questions, evens, odds? Did we answer? You guys didn't stop me, but there was something else? I thought we had something. It was 48. Yeah. He's a gnarly one. He had little tiny baby numbers. So the key was following what we did in class, but then the next key was making this jump, which was a really weird one. It's a good jump to learn, but it's really weird. Alright. So if we're good, let's go ahead and move back to notes and learn about some hyperbolas. Not hyperboles. Ooh, what's hyperbole? That's English.
Oh.
Oh, it's an exaggeration.
Exaggeration. We'll try not to have any hyperboles about hyperbolas. Alright. Let me get out of this. Let me get out of that. Let me minimize that. Let's get back to it.
So tired.
Is it too warm? Don't worry. I got you.
No,
I'm wide awake.
Whoa, what happened?
Where's she going?
The stylus clumped on the, and I don't even know.
Come back.
Maybe there's a shortcut. Oh, there's a shortcut. Oh no, there's not.
It's
Just like that. That's cool. Anyway.
3D volume? No, I'm still gonna. Who are you?
Who is she?
You guys don't even see the cool pictures yet.
Wait, it says 12.3 handout. Does that mean we're not going to do it in our...
There's a 10.1 to 10.4. Actually, we should probably talk about this. Guys, when you look at your homework sheet, if you notice, it goes 10.1, 10.2, 10.3, 10.4, 12.3. Huh?
Oh, yeah.
And it's not even our 12.3. It's another book's 12.3. It's actually this old little baby pre-cal book's 12.3.
Oh, that's my...
Look at him.
That's a pre-cal.
I like
Yeah.
Nice. Why can't we have some?
Oh, I should have kept this one, huh? Ready? How many words are in here?
Too many.
Words are better.
Oh. It's better. It's like
Bye.
the same thing, but smaller.
You guys
Too
notice
many.
how many words?
Yeah, there's a lot of words.
Like this is one of the first. Oh, this is the first homework. Ready? Words.
Oh my god.
Words. Words. Words.
Wow.
That's the second homework. And then let's see what that homework's like. Okay, there are a few little equation example things. Not too bad, right?
Pre-cal.
Third homework. Oh, it's not too bad.
But then that means
But if you
less
guys look at the
problems.
majority, it's just like words, 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 words.
That means there's less problems.
I love this book. But
Nope.
I realized that even though it was good on the conceptual, it was good on the word problem and the analyzing, all that sort of stuff, the critical thinking, there were basics that were getting lost because you weren't practicing them. If you look at your homeworks, there's a lot of basics that we're practicing and a few words here and there. So, I know, I changed it. It was my bad. But at the same time, you remember that I am what kind of teacher?
The good
This one, well, I try, but I wouldn't say that. But what else, what other kind of teacher am I?
Calculus.
Calculus. And this guy
This is the calculus.
is the same as the calculus guy.
So
And what he's introducing and the skills that he's trying to have you guys master in the practice is what you're going to need for the standardized AP test, which I am also trying to prepare kids for. Wait, standardized testing? That's lame. We should sue.
And it helps you
Then
really
you
well
can't
for
go
the
to college.
And it prepares you really well for the
Math
SAT.
entrance exams for college, so you don't have to go back to Algebra 1 and start all over again. That's a thing. Anyway, here we go. I know, I understand. The little book was nice. Kiddos, we already talked about, I think I pretty much already pointed out a lot of things. I'm not going to write anything on this page, except I'm just going to point out some stuff. Like, you guys saw this horizontal transverse axis, right? Then question, we better label something. What is the transverse axis? What's something horizontal in this picture? Yep. The horizontal transverse axis is the line that cuts through the hyperbola. The transverse axis is the line that cuts through the parabola. Think transcontinental. Ooh, the transcontinental railroad. What'd that do? It went across, right? It went through. So think transverse axis is going through the hyperbola. Does that kind of make sense? Silly way of remembering. For my push people. Push people. Now, hold on, pause. There is one thing I actually realized that I don't show on these pictures, or that don't show on these pictures. There is another axis, technically. Transverse is the one that goes through, transcontinental railroad. The other one is called the conjugate axis. And the conjugate axis is the one that is perpendicular to the transverse. So transverse goes through, crosses through the hyperbola, crosses through both branches of the hyperbola. Conjugate is the one that's perpendicular in the middle, going through the vertex. Okay? Now, we could technically do the exact same thing down here if we wanted. I'm just not going to label them again. Transverse goes through. Do you guys see how it's vertical now? The vertical goes through. We could call it vertically oriented, whereas the conjugate now is the horizontal. Okay, we have all these formulas. Let's try to at least get to some examples today, even though we're running out of time, but that's okay. We've got a lot written down. In the formula. In the formula. We have our vertices. We have our center. We have our center at HK, just like we're used to. But what's different with the ellipses and the hyperbolas in the formula? Number one, let's highlight the subtraction. What's going to be different is the subtraction. And since there's subtraction, here's the dilemma. With ellipses, it didn't matter because addition is commutative, right? A plus B is B plus A. So we just kept the x term on the left-hand side the whole time because it was easier. But with subtraction, can we keep, if things need to switch, can we keep them written the same way? No. So instead of switching the A and the B, what switches now for the orientation is going to be the entire x's and y's. So what's kind of weird in this one is that you have to pay careful attention to who is understood positive. Who is understood positive? And here's my meaning. When the x term is understood positive, when the x term comes first for a hyperbola, it's going to be a horizontally oriented hyperbola, aka it's going to be one of these ones. When the y term is positive on the next one, it's going to be a vertically oriented set of hyperbolas going the other direction. So that's a huge clue to pick out of an equation when we're looking at it. Which one comes first? X. Okay, cool. Y you can fly, X you can... What's the X one? Y you can fly. X you can run? I don't know. Anyway. I forget Mr. Shanks' way of remembering it. But X is, since the X... What is it? Y you can fly, X... X comes first. X you can... No. What? Is it X you can run and Y you can fly? That doesn't sound right. Maybe it's right. Okay, but anyway, with the x, just think it's going to be horizontal. With the y, just think it's going to be vertical. Now, guys, a couple things with that. Remember, if it's horizontal, just like the picture shows, the center will be where the center is, but the vertices go right, left, and the foci go right, left. Then down below, for the vertical ones, the center is where it is, but the vertices go up, down, and the foci go up, down. You guys had it on the page before. It's just a quick little reminder. Now, here's something, though, that we didn't write on the page before. So you guys get down to the asymptotes?
Yeah.
Wait, I don't see any asymptotes. Do you guys see any asymptotes? Sorry, Jacob, you got asymptotes. I see transverse axis cutting through. We talked about the conjugate axis. Transverse, conjugate. Where are the asymptotes?
Isn't it?
There's slanty ones. There's slanty ones. So actually, you know what? I'm going to erase my hyperbolas and I'm going to be like, not my favorite. They weren't very accurate. Why not? Because there should have been asymptotes that they follow. Now, check it out. You don't actually see the asymptotes in the figure itself. If we were to graph these on like a graphing calculator, they wouldn't be there. But the branches of the hyperbola follow them. See it? The branches of the hyperbola follow them. Now in this one, if you guys check over here with the different parts of the equation, A goes with X and B goes with Y. If we think about the slopes of our asymptotes on these ones, we could say M is equal to plus or minus, because you have two different lines. You have one with a positive slope right here and one with a negative slope right there. M is equal to plus or minus, let's see, which one goes with Y in that equation? B, right? Over, which one goes with the X's? A. That's how we would find the slopes of the asymptotes. That would help us do the rise over the run from the center. So the rise would be the B, the run would be the A. But what's going to be different down below? Now, once again, I don't really like my hyperbolas, because they weren't following asymptotes. So make them a little bit nicer. Okay, my hyperbola branches are going to follow again. Follow again. My hyperbola branches are going to follow and follow. You guys see it? Okay. Don't my asymptotes need little slopes again? You're still laughing at them. I have a positive slope 1, I have a negative slope 1, hence why the plus or minus. I'm going to have a rise over a run. I'm going to do a run over a rise just so it doesn't intersect with the rest. But question, kiddos, over here in the equation, what goes with x now? And what goes with y? So we'll say plus or minus on this one, technically a over b. But no matter what, even though that can get a little bit confusing as to which letter to use, the long story short of it is just take whatever coefficient is for the y term and the coefficient that's for the x term. That'll help you stay honest. Because the b just, whatever, it was the one that goes with the x, yeah, that should be in the bottom. The one that goes with the y, whatever, that should go at the top. Same thing up here. It's not so much you need to memorize the b's and the a's as just understand the rise needs to go on top and the run needs to go on bottom. Now, you guys could write that in that blank, or you could just write that down below. Because I just say they're going to intersect, the asymptotes are going to intersect at the center, so we just start at the center and do our rise over our run based on the coefficients. And the coefficients, we're just going to say rise over run. Rise, remember, it's the one that corresponds to the y. Run is the one that corresponds to the x. But don't forget that it's plus or minus. Now, the nice thing is, kiddos, is that this is a day 1 of 10.4. We have all the key information. We have the formulas. We have the hints as to how to make a graph. But tomorrow we're going to have to see lots of examples. Ready? Just check. What if they give us the clues and we need to make the graph or the equation? Oh, mark the lose. Oh, what if they give us... Oh, ho, ho. Woo! Why is this one like 48? It needs to complete the square.
So do you suggest we start tonight?
I think you could start tonight,
Okay.
but we'll do lots of examples tomorrow to help where you got stuck. Is that cool? Alright guys, we'll finish up tomorrow with our examples. I'll see you guys later. If you need me, I'll be here lunch after school.
There.
Hello, Steve. Hi.